Welcome to the Property Regeneration Podcast. In this podcast, we discuss innovative products and services that meet either local, social, technological, environmental, political, and legal needs within the construction industry or property market. Introducing your host, a property developer and investor, Rachel Gross.
Hi, I'm Rachel Goss. Welcome back to part 2 of the discussion on Advanced Manufacturing Research Centre. If you missed part 1 of the discussion, you can find this on our previous episode.
Okay, brilliant. Is there anything else you'd like to highlight within the industry that would be of use or of interest to our listeners within construction as a whole?
Well, I suppose within construction, I think
Where do you see the future of construction merging with IT? Because you hear a lot about the smart building, the smart city, and I guess you don't hear so much about how the everyday architect can implement that in their everyday design. I'm saying that because previous interview to this was with the Chartered Institute of Technologies, and I asked the same question. His take was that they tend to do the design separate and then discuss the digital aspect with the supplier, and then somehow merge the two together. So it'd be interesting to hear it from your view. How you see that relationship between IT and the traditional brick and mortar architect. So the IT architect versus the construction architect, the two roles in a sense.
Well, I think
working.
In the construction of buildings, technology is playing a more important role.
Yeah.
And that's from anything from a domestic house to a big office block. One of the kind of challenges, and then again it comes to our commitment to 2015, which is that we want to be a zero greenhouse gas emission country by 2050. That would mean that if we're building new buildings and we're retrofitting existing buildings, they need to change. So a good example of this is the concept of the passive house. Passive house is a house which is it uses the natural heat of the sun.
That's right.
But it also needs to have controls in it so that if it doesn't get too hot, the building doesn't overheat. Similarly, in winter, it needs to be able to manage the airflow. And so if you're looking at a house like a passive house, you need technology in there to control it. You need to understand what the temperatures is. You don't want a house to get too moist, because the risk is that you've built this super insulated house with these super glass windows, but you need to ensure that you can reduce moisture, so you need an airflow system in there. And for the airflow system to be most effective, you need to put sensors within the house, and those sensors will provide information back to the central unit, which is controlling the environmentals of the house, such that it then, minimises the energy footprint needed, but also optimises the environmentals of the house. Similarly, there are lots of sensors we're beginning to put into houses. You walk into a room, the light comes on. You walk out of the room, the light comes off. You individually control the temperature and the environmentals of each room, even to the point where people are trying to control the environmentals of each half of the room. But all of this is dependent on technology. So the house needs to be designed with technology included within the fabric of the building. It also needs to be able to upgrade it. There's no point putting cables in to walls which are going to have a finite life. So technology changes very quickly, and the technology you put in your house will probably not be the technology that will be there in 10 years, 20 years. But when it comes to the digital building, it keeps rolling back to this concept. Digital is about data. It's the fourth utility is data. And so if someone is living in a house, they need to be able to make the decisions about what is the most optimal pathway or approach I can do to reduce the energy consumption in my house, to make my house more sustainable. And that only really works if you can provide them with the information. Fortunately, it's getting easier. So when we first started, you actually had to buy these big things that you put onto the plug and connect it to the light switch, and then you could start collecting data and saying this light uses more data, that light uses less data. And I've, being a bit of a technical guy, I've done this. And then you can start realizing, well, hold on a minute, why is this light on all the time? And why am I consuming more energy here? And it's by providing that information in a format that people can use. There's no point having huge amounts of data, which we can't do. Provide them with simple dashboards. And it clearly says, okay, I'm using this much on my kettle, I'm using this much on my light. If I do these things, then I can reduce my energy consumption. Now, I had a really interesting one. I've got a light switch that's outside, and when you open the door, it turns the switch on. Yeah. But obviously it's on all night and on all day, and I can't see that because it's out the front of my house.
That's right.
But when I put my sensors in there, I suddenly realised I've got this. Why is this light using more electricity than all the other lights put together? And then I had a close look, and I realised if you open this door, it turns the switch on, and then no one notices because during the day you can't see the light, and at night nobody goes out there. And it's just by providing that information, I had the information, I could see the information, and then I realised, hold on a minute, if I do this small change, I will stop these lights being on all the time, and I will reduce the energy footprint on my house. But where the big change is the pathway we seem to be following for climate change mitigation, which is we're going to go away from carbon fuels and we want to use renewable electricity sources. Yeah. Now, this will make a big change into that in specifically domestic houses. So instead of having gas, you're going to have electricity to power your heating. So either an air or a ground heat pump system. Your car will probably change. So instead of driving around in an internal combustion car, you'll have an EV, which will need to charge up from a big high-speed, high-power charger in your basement or in the street or in some areas. Yeah. And if you're doing this, and this pathway says that energy consumption isn't going to drop dramatically, but there's going to be a big shift. It's going to be a shift away from consuming diesel, petrol and gas to everything running on electricity. Yeah. Now, we might come up with a different technology, but at this point in time, this is the pathway that we kind of have in front of us, and we can see this happening. We have the amount of investment that's going into electric vehicles now is huge. That's right. But then if that's the case, then we're going to have to be a bit more clever about how we consume the electricity, because we know that renewable sources are a bit intermittent. And if you have a PV on your roof and the sun's not shining, there's no electricity. If there's no wind blowing, there's no wind turbines. Yeah. So we have all of these cars with their chargers, and they provide a source of electricity, but they also need to consume electricity. So we can only really consume the electricity when it's available. When it's not available, we can't really consume it. And that will require a lot of intelligent technology to understand when we charge the car, when we don't charge the car, when the fridge needs to be running and not running, when we put our washing machines on. So as we move towards smart meters and smart meters getting smarter and smarter, we then can be more specific around how we would then draw electricity. But that is going to mean that houses are going to have to get smarter and smarter, but also the devices in the houses are going to need to communicate with each other. So when a house is being designed and built, and the underlying infrastructure, so not just the house, but the street, and all the utilities going into the street, is going to have to start getting clever. And so when the planners and the architects start designing these new buildings, technology will need to be part of that, because the technology is going to help us decide when we can consume the power, when we can't consume the power. And the technology is going to then hopefully mean that we don't need to generate as much electricity, and we don't need as many renewables as we would necessarily have.
So how would you describe the relationship between the IT industry and the architecture industry when it comes to designing and creating our environment, whether it's the infrastructure or the actual buildings themselves? How would you describe the relationship? Is it robust in a sense that with the feeding off each other ideas to come up with a solid design, or do you think both industries still have a long way to go to actually reach that sound relationship towards meeting the carbon emission goal for 2050?
I think everyone is on the same page. So I think that they kind of understand that these two elements are directly linked. But on the positive, architects have been using technology for a long time. I mean, house design is done using 3D rendering, 3D viewings, but also in the construction industry for the commercial buildings. More and more commercial buildings are being automatically prefabricated in factories. So for a prefabricated building, you have an architectural viewpoint of a design. That design is then submitted to the machines, and machines then start prefabricating the building. So the relationship between technology and building is a long one. Also within commercial buildings, like the one we're sitting in here, there is a computer somewhere managing all the environmentals.
That's right, yeah.
So building environmentals have been computer controlled for a very long time. All of the assets within large buildings are managed and controlled through central compute. So computers been within buildings for as long as there's been computers. And particularly as we move now towards a view of future of house building, the role of prefabrication is getting more. There's lots of government initiatives saying we should prefabricate more buildings, and we should build them in factories where we have the same quality control that you would have for any other thing manufactured in there.
That's right.
And they then should be constructed on site with minimum input. For that to happen, you need to use technology. And another interesting interaction I had within the construction industry was going to one of the Industry 4 locations up in Sheffield, where people would be using the VI glasses.
Oh yes, yeah.
And so with the glasses, you could then project a vision of what the building would look like, or how the factory looks like, so that the actual architect can walk through the factory and understand whether it had been built in a way that there were no funny things that you couldn't see. So technology is now allowing you to render in 3 dimensions so that you can then visualize what it is you're building and how you actually interact. So I don't see architects, and I don't see the construction industry as being behind the curve on technology. I mean, in certain areas of technology, particularly in trying to understand all the bits and the processes in the supply chain and all of the components that are needed to construct and manage big construction projects, they're absolutely at the cutting edge of technology. They are driving the requirements for us within the technology industry in terms of what they want us to do to help them better construct buildings.
That's good to hear. Good to hear. Anything else you'd like to add to discussion?
No, I think we're okay. I think with everything. I mean, I just would go back to the whole starting point, which is we as technologists, we have to be clear that we can help construction. We can help people in terms of being more sustainable, but we have to be careful that we don't just put technology for the sake of technology. And then we have a worse effect, because at the end of the day, computers use energy. We want our computers to help reduce the energy. We want our computers to help the amount of waste being created. But we create a fair bit of waste. I'm just going to look at my number, which I've written down here, for the actual amount of waste being generated by compute. Right, so we are around about 65.4 million metric tons of e-waste being generated every year, and by midway through this decade, we were only recycling 15-20% of that. So there is no point us creating all of these wonderful things for people. You know, we have to be clever about how we build our technology, so that we can recycle it, and we need to reduce the amount of waste we create. But then in the other thing, technology can be an extreme enabler to help people going forward. It can help people make decisions which are more sustainable. But it's a double-sided coin, and we've got to be careful that we're not generating more problems than we're solving.
That's true, and to me, it's a real eye-opener, the amount of wastage you've just quoted there, because now I'll be intrigued to know how that compares with the construction waste.
I think construction industry is pretty good now. You can. I was reading one of the house companies who are pretty much 100% recycle. So they'll take the concrete from the foundations, they'll reuse it, they'll reuse most of the building materials from existing houses.
Yeah.
They don't throw it away, it gets recycled, reused, it goes back into the supply chain. It is a true definition of a circular economy.
Yeah.
Right now, a lot of the e-waste gets put on a ship. It gets taken to countries with lower standards.
Yeah.
And it just gets dumped. And that's not necessary, because you can recycle 100%.
Quite a lot, yeah.
You can take 100% of the e-waste you can take within the UK and put it into there's a big factory, I think somewhere near Wales, and a computer goes in one end and all the component parts come out the other. But it's more expensive. And I think that you have to take responsibility for the waste we create. That waste needs to go and it needs to be recycled. And it's really not fair that we then put it on a ship, take it somewhere else, and hope that somehow they're going to solve the problem, but they can't. So it just ends up being dumped. And there are some toxic components within computers which really needs to be managed carefully and recycled carefully.
Yeah. The interesting fact again that I didn't know, you could do that. There's something digital through a machine and then it pulls out components at the other end.
Sucks all the copper out, sucks all the elements out. But then there's some things like rare earth metals in there.
Yeah.
In very small concentrations, and although it's quite difficult to recycle them, it can distribute them such that they don't build up in concentration. But if you're dumping lots of huge amounts of e-waste in one area, you're effectively taking elements which have never really existed naturally in large concentrations and running the risk of actually increasing the concentration of those elements over time. And we shouldn't do that. So we should be a bit more careful.
And can those components, in a sense, be melted down and reused?
Most of them can.
Into new components.
Most of them can. I mean, so lots of materials like copper, solder, some plastics in there, and these can all be recycled. Okay. Some of the very, very specific rare earth metals are more difficult to recycle now, but because their value is so very high, provided that it's economically viable to do it, there's no reason why you shouldn't. Yeah. But we need to encourage that behaviour, and we need to discourage dumping it places where it's got rid of cheaper. It needs to be included within the cost of the technology needs to include the cost of the recycling, and then we need to recycle them responsibly.
Okay. So just to close off, could you describe in one sentence what the word digital means to you?
Digital to me means data. I mean, it is just the digital revolution is putting information systems into things which were previously done and extracting data from it. And what digital does is put that data into the hands of the people. But if we boil down to its single component, it is just information, it is just data. That's what digital is.
Okay. Brilliant.
Okay.
Thanks very much.
That's okay.
Thanks for listening to the Property Regeneration podcast. You can follow us on LinkedIn, Twitter, Instagram and Pinterest, and contact us on contact@propertyregeneration.co.uk for more content and to have your questions answered. Until next time, adopt innovations to accommodate the growing population.